Last year Apple launched their own chip into market with great hype. This chip is really special to them. They released this under the banner, Apple Silicon. It reached the expectation with ease. Today we're going to tell you how it achieved such a great performance, even though it's first of its kind. Welcome to all. Before diving into technical details, we're going to learn a history lesson quickly. Let's look at the timeline of processors used in Macintosh. These are the processors used, and now using by Apple. Initially, they used Motorola processors for their Macintosh computers. The first Motorola Macintosh computer was released in 1983. Motorola 68000 was the first Motorola-powered Macintosh. Macintosh 2 is a huge success, which used MC68020 processor. It's the first Macintosh that's supporting color graphics and upgradable hardware. But to withstand in market and to keep the pace up with IBM PC compatibles running on Intel processors, Apple discontinued Motorola processors for their Macs. Huge respect to Motorola processors. Here arrived the second generation processors. PowerPC is combinedly developed by Apple, Motorola and IBM. This is a great step by Apple to set the company in one of the top positions for a decade. In this era, people have seen Macintosh computers in many forms, as shown here. After few years, when PowerPC is compared to Intel, in performance per watt category, Intel is nearly 4 times better than PowerPCs. So, they thought of shifting to another processor by keeping PowerPC aside. RIP. Removed in peace. And the third generation processors are obviously Intel ones. In the era of Intel processors, the Macintosh computers haven't seen many new forms. But the form factors changed in an unimaginable way from log to stick size. These are a list of some of the Intel processors used by Apple in their Macintosh computers. To overcome the limitations caused by hardware and software compatibility troubles, Apple thought of inventing their own chips. So, after more than a decade, Intel Macs have reached their olden days. Finally, the fourth generation has begun with the invention of their own chip. M1, a new era. Coming to technical details, we all heard Apple M1 is an ARM-based chip. But what is this ARM-based concept? To know this, we should know about instruction. The computers are just dumb electronic caskets. What makes them alive is instruction. Without instructions, computers doesn't work. Based on different philosophies, there are two main instruction types. They are, number 1. Complex instruction set and number 2. Reduced instruction set. The philosophy behind complex instruction set is, code density should be high. In olden days memory used to be costly, and consumes more room space. So, instructions are designed as, the software should consume less memory, but the work done by it should be maximum. Later, at the time of Intel started walking, these instructions evolved as complex instruction set. This set got famous after development of x86 instruction set architecture for 8086 microprocessor by Intel, which is based on complex instruction set. But, after few advancements, this x86 architecture got messy. The philosophy behind the reduced instruction set is, no one uses complex assembly language like complex instruction set. This notion as backbone, IBM first developed reduced instruction set. But, with reintroducing reduced instruction set, Acorn Computers invented a processor named Acorn RISC Machine, which is an acronym for ARM. This chip worked on residual power, which means it has very low power consumption. This company started licensing their architectures after the failure of their computers. Nowadays, any chip which uses this company architecture, it is known as ARM-based chip. So as M1, Apple claimed M1 is the first SoC in PC category. So let's know what it is. SoC, system on a chip. First of all, let us tear down a laptop that is already existing in market and observe how they are built. So, we can understand the SoC concept better by comparing. Here is the stripped laptop. Come on, let's analyze the circuit. On the top of circuit, there are a lot of copper pipes, which are used to emit the heat as soon as possible. The component below the heat pipe, on left side is none other than CPU and, the right side one is GPU. The chips under the black sheet, which is located just below GPU is RAM. In this laptop all components are connected individually on a motherboard. So, if we observe a system on a chip, all components required for processing like, CPU, GPU, RAM, company customized components, connectivity, and other circuitry are built on a single chip, which means, a complete system on a chip. This type of technology mostly used in smartphones, because of their form factor. There are three main points to be discussed about SoC. Number 1, all the components, which do processing on a computer, are embedded onto single chip, so, when both technologies are compared, in SoC, a signal takes less time traveled from one component to other component. This results in increased speeds of execution, which means minimum lag in execution. Number 2, since the execution time of a task is reduced on a SoC, automatically duration of a chip working for a task is reduced. So, the chip will remain idle for the remaining time. This decreases power consumption of a chip. So increased power efficiency. Number 3, there is no upgradability in hardware of an SoC. This is because of integration of all components onto single chip. We can't change the components of any integrated circuit. This is the main drawback of SoC. Here is the M1 SoC clip. As we said earlier, CPU, memory, IBIO chip and other components are integrated onto single chip. So, it has all the advantages and disadvantages of a SoC. These are the features of M1. Let's know more about its CPU and GPU. CPU and GPU are the basic building blocks of a computer. Full form of these terms says, Central Processing Unit and Graphics Processing Unit. Both are used for processing only. Then, how they are different from each other. To understand this better, we will first know about what does processing mean. Generally processing means, collecting the data from user, and manipulating it, as per requirements and giving accurate output. Actually processing is more likely of, manipulating data. Processing involves three main operations. They are, arithmetic, logical and, bit manipulation. Arithmetic operations involves simple mathematical operations like addition, subtraction, multiplication and division. Logical operation is a special symbol that connects two or more phrases of information. These include and, or, not and, etc. Bit operations manipulate the data in bit level. For example, if we move bits right side by one digit, the result will be half of the previous number. Bit operations includes bit shift, bit toggle and, etc. All these operations are performed by arithmetic logic unit, ALU. So, more number of ALUs means, more the processing power. Now coming to CPU and GPU, as the name says, CPU performs central operations like coordinating, word processing and mathematical calculations, whereas GPU process all the graphics of high-end softwares like AutoCAD and games like Fallout and etc. Generally, CPU has fewer number of ALUs and GPU will have multiple number of ALUs. M1 has an 8-core CPU, in which 4 cores are high-performance cores, which handles higher workloads. And the other 4 are high-efficiency cores, which handles lighter workloads and use only 1/10 of the power. This is the world's first integrated 8 graphics core chip. This GPU has total of 1024 ALUs, which can handle the processing balancedly. Now coming back to features, let's focus on unified memory. Unified memory reduces execution time. Unified memory means, single memory for multiples processing units. To understand this, let us see some laptops in market. Here it shows 16 GB and 8 GB graphics. One for CPU and other for GPU. And look at this one also. It shows 16 GB which is for CPU and 6 GB which is for GPU. Basically, in this type of systems, each processing unit has separate memory, and they are connected as shown here. Let us process a photo now. This photo is converted into binary form and loaded into RAM. And now it is sent to CPU. After basic processing, for more graphics processing, the CPU will send this to GPU, via memories as shown. After GPU finishing all the processing work, it sends the data back to CPU via memories. Because of use of two memories, data needs to be loaded and sent 2 times, which increases execution time. But in unified memory, both CPU and GPU will have single memory as shown. Now let's process the same photo. As said earlier, binary data of the photo will be loaded into RAM. Now on call, it sends the data to CPU. Same as earlier, after processing of basic details, for further processing of the photo, it is sent to GPU, via single memory. But now after getting data from CPU, it directly sends to GPU, not to another memory. Means loading and sending data takes place only one time. So, the execution time reduces by almost half of the value. This is the advantage of unified memory. The shiny colored area is whole processing unit, and on the right side, there are 2 black rectangles. And those chips are the common memory, for whole chip. This is why M1 is said to have an unified memory architecture. In the final analysis, these are the main reasons for such a high performance of an entry-level chip from a company. And we are Team Techie. Thank you for watching us, and we'll meet you soon in the comments section.